This is a graphic cross-section of Lil Squirt showing the fact that if you put a 10 microliter syringe beside this, that's the distance you would need to move these tiny volumes. The graphic shows that to take 1 microliter, you'd have a gigantic quarter of an inch to move. For 200 nanoliters, you'd have 50 thousandths, and for 100 nanoliters, you would have a very generous 25 thousandths of an inch to move. This is why one gets such extreme precision and accuracy in the differential mode of this device. Here are 100, 200, and 300 nanoliter drops that have been dispensed by Lil Squirt's differential mode. Observe the distance that the pistons move together now. To dispense 0.1 microliters, 100 nanoliters, 24 thousandths of an inch. For 200 nanoliters, 48 thousandths of an inch. For 300 nanoliters, 62 thousandths of an inch. Very generous distances. Again, 100 nanoliters, observe the visible, ample 24 thousandths of an inch. 200 nanoliters, 48 thousandths of an inch. 300 nanoliters, 62 thousandths of an inch. Same distances that a 10 microliter syringe would move to meter those volumes, except unlike a 10 microliter syringe, which would be hopelessly impractical because of bubble hang-up and sealing problems and leaking, this unique patented differential mechanism of the DRD Lil Squirt uses these husky pistons with robust compression seals and can meter these tiny, tiny volumes as finely as if you were moving a pin or a needle through that liquid. This is Lil Squirt doing a tiny sample aspiration into a disposable tip and then a touchless blast-off delivery. First we pick up a disposable tip, and then it primes the tip through with internal liquid, then aspirates a controlled separating air gap. Then those pistons return to the top, or the differential mode. And in this program number 40, it's going to aspirate 2 microliters. So watch those pistons move together and by differential, smoothly and accurately aspirate 2 microliters into that tip. Then in the high flow single mode, it will blow that sample off. We'll move now to the next program 41 for 1 microliter. We'll stay with the same tip, flush it out, aspirate the separating air gap. Pistons will reset now to the differential mode. And now watch those pistons move together and by differential, precisely and accurately and smoothly aspirate 1 microliter sample. Then the pistons again shift to the single mode where they have the huge flow power to blow that 1 microliter sample off discreetly. Then we will move to the next program. We'll stay with the same tip here. Prime it through and take in our separating air gap. And this program 42 will call for the aspiration of 700 nanoliters, just so you can see the difference in drop size. So watch those pistons move together now to aspirate precisely 700 nanoliters. And then again we go to the single mode where we have all the flow power we need to blow off that 700 nanoliter sample. Well, we're going to show as best we can a close-up of Lil Squirt doing this progressively smaller sample pickup and touchless delivery. First, we'll aspirate the intervening air gap. Then aspirate in the differential mode smoothly and precisely a 2 microliter sample. You can see the height of it in the tip. And then going to the single mode where there is tons of healthy flow power, we blow that off touchless. We're then going to advance the program to program 41, which will do this for 1 microliter. We'll purge the tip out with internal liquid again, then aspirate an intervening air slug. Pistons set to the differential mode again. Then precisely and smoothly in the unique DRD differential mode, aspirate 1 microliter sample. You may recognize the height of that is less than the prior one. Then we will position over the cap again, and with the high flow of the single mode we will deliver touchless 1 microliter. We'll then advance the program to program 42 for, as a frame of reference for you, 700 nanoliters. We'll flush the tip through again. Aspirate 12 microliters of air again. Pistons reset to the differential mode, in which we will now smoothly, precisely, accurately aspirate 700 nanoliters. You can see that's a little bit less tall than the 1 microliter. Then reset to the single mode and blow it off contact free. In manual focus now, this is a close-up of the 3 drops, 2 microliters, 1 microliter, and 700 nanoliters that Lil Squirt just picked up in the differential mode and delivered by touchless blast-off individually. You can see the nice size proportionality. When you weigh these, they weigh as you would expect those volumes would weigh. Overall shot in manual camera mode of a little Maldi program. We will first take a new tip, prime the tip through, aspirate 12 microliters of air, the pistons will set to the differential mode, and now with the resolution of a 10 microliter syringe, we'll very precisely withdraw 1 microliter of this reagent. You see it in the tip there. And then again in the same differential mode, we'll aspirate 1 microliter of separating air. Sets again in the differential mode. And we'll now aspirate 1 microliter of yellow reagent, which could be serum. And now, let me clean that off, we will blast off these two together into a nice green, because blue and yellow makes green, 2 microliter drop. You can see that on this. It's a close-up of a little Maldi program with a disposable tip that's been primed through with liquid. We're going to take up 12 microliters of air. Just an arbitrary, very generous separating barrier from the internal fluid. Now in the differential mode, you'll see the pistons move the generous distance they have to aspirate this 1 microliter of reagent precisely and smoothly into this disposable tip. Pistons reset again to the differential mode. We'll take up 1 microliter of air. Reset again in the differential mode. Now aspirate 1 microliter of yellow sample. Here we have it in the tip. And now we will deliver by clean blast off 2 microliters, as expected, of a green liquid, because blue and yellow make green. This is a close-up of that nice green drop, which the reference grid shows is just about 2.3 millimeters in diameter. First we pick up a fresh tip, dispense 100 microliters to prime it, aspirate 25 microliters in the single mode. Now aspirate 14.8 microliters in the single mode of reagent 1, which is blue. Aspirate 10 microliters of air, also in the single mode. Aspirate 15 microliters of the second reagent, which is green, single mode. Aspirate 2 microliters of air, which is done in the differential mode. And now aspirate 200 nanoliters of sample, precisely and accurately in the differential mode. Then dispense everything together. Then the pistons reset to the top of the differential mode. And now it's going to aspirate 2 microliters of air separator in the differential mode. So you will see the entire movement spanning the entire differential zone there to take up that 2 microliters of air. The same movement that a 10 microliter syringe would have moved to do that. And now the pistons are positioned in the differential mode for this most critical differential mode pickup of 200 nanoliters. And you'll see these pistons now move the same reasonably generous and certainly visible distance that a 10 microliter syringe would move to pick up 200 nanoliters. You are looking at the 200 nanoliter sample and 2 15 microliter primers or reagents that have been aspirated. Then the pistons reset to the single mode in anticipation of dispensing now 58 microliters, both reagents and sample, and the cycle is completed. First, we pick up a disposable tip and then flush it through with internal liquid, and then we'll take, in this case, a 5 microliter separating air slug. Then you'll see the pistons reset together in the top at the differential zone. Now we're going to aspirate 500 nanoliters, a half a microliter, precisely in the differential mode. You can see the long distance those pistons have available to them to actually aspirate 500 nanoliters, if you can see it in the tip here. Then you'll notice that the piston has reset to the bottom, and basically it's going to now eject that 500 nanoliter sample along with 1,000 microliters, a full ml of internal fluid. And we're going to do this relatively slowly so that you can get the impact of it. There's the sample, and it's following that 500 nanoliter sample with a full milliliter of internal fluid. That's a dilution of 2,000 to 1. And the point to keep in mind is that 500 nanoliters was aspirated as precisely and accurately as could have been done with a 10 microliter syringe, which is hopelessly impractical for laboratories, but totally practical with the DRD system because of its dual resolution capability. This is a close-up of Lil Squirt doing a 2,000-fold internal dilution of a 1/2 microliter sample with a disposable tip. First, the tip is primed through with internal liquid, and then an air slug is aspirated, 5 microliters in this case. Then the pistons reset to the differential mode, and when we actuate it here, you will hear the duration going with the long excursion that those pistons moving together actually have to precisely and accurately aspirate a 1/2 microliter sample as precisely as if this was a 10 microliter syringe. It's aspirating now, and there you see, hopefully in this view, a precise and accurate 500 nanoliter sample. Now the pistons have reset to the single mode, and we're now going to dispense slowly so you can see it. This 500 nanoliter sample followed by a full 1,000 microliters or 1 ml of internal liquid. There goes the sample, and you can see the stream of liquid. This cup is filling right up to the brim, which happens to be 1 ml. So that is a 2,000-fold internal dilution with a disposable tip with a single pump, in which the precision and accuracy of the aspiration of the tiny 500 nanoliter sample is as good as you would get from a 10 microliter syringe. Unlike a 10 microliter syringe, however, the DRD, operating with Husky pistons in differential, has no problems at all with bubble hang-up, priming, leaking seals, or any of the other things that have made 10 microliter syringes hopelessly impractical for practical applications. Not so with the DRD Lil Squirt. This is the DRD Lil Squirt doing a 10,000-fold dilution of a 100 nanoliter sample that it is picking up in a disposable tip. With program 53, first the disposable tip is flushed through, and then a separating air slug, 5 microliters in this case, is picked up. The pistons then reset to the top in the differential mode, where the two pistons are moving together with the differential resolution of a 10 microliter syringe. And now we'll go into the sample, and we will, by differential, precisely and accurately aspirate 100 nanoliters. If you can see that in the tip there, 100 nanoliters. Now we're going to go over this cup here, and slowly, so that you can appreciate the phenomenon that's occurring here, we're going to deliver that 100 nanoliter sample followed by 1,000 microliters or 1 ml of sample, of diluent rather. That is a 10,000-fold single-step dilution of a precisely and accurately picked up 100 nanoliter sample. One simply can't do this with syringes, and it's useful to think about what possible things one could do that are useful that one didn't think about before because the technology just didn't exist to do it. one can pick up a sample in a disposable tip and then repetitively dispense tiny volumes. This is a disposable tip that's been primed through with liquid. We'll pick up a air separation gap and then we'll aspirate 15 microliters of reagent here. And now we can deliver successive, in this case 2 microliter droplets if we want, on this plastic cap. This is a close-up of those drops. You can see they're basically all the same size, and though the comparison grid doesn't show well here, these drops happen to be about 2 millimeters in diameter. Little Squirt with a disposable 30 microliter low retention tip. We're going to flush the tip through. We're going to take up 5 microliters of air, and then we're going to aspirate 15 microliters of a red sample here. And then in the exquisitely fine DRD differential mode, we're going to extrude and touch off 200 nanoliter samples consecutively. And even manually touching off what would normally, of course, be an automated operation, you can see what I can tell you is visually drops that are virtually the same size. By comparison with the blue grid above, these drops are just about 0.9 millimeters in diameter. Now we're going to do the same thing but with the blue dye. With the differential mode resolution of a 10 microliter syringe, we're going to flush through a new 30 microliter low retention tip and then aspirate 5 microliters of air and then 15 microliters of a blue sample. And now in the differential mode, we're going to deliver 200 nanoliter samples and touch them off. You can see, even with touching these off by hand, what would normally be a highly precise robotic operation, you see almost perfect consistency in the size of these 200 nanoliter drops. We're now going to do this 100 nanoliters, 200 nanoliters, and 300 nanoliters in immediate succession, manually by touch-off. And you will see extraordinary size delineation. Program 61 with the differential resolution of a 10 microliter syringe. We're now going to pick up 5 microliters of air in the tip. Then pick up 15 microliters of reagent. Now we're going to dispense 100 nanoliters. 200 nanoliters, 300 nanoliters, again 100 nanoliters, 200 nanoliters, 300 nanoliters, 100 nanoliters, 200 nanoliters, 300 nanoliters, 100 nanoliters, 200 nanoliters, 300 nanoliters. You can see on this cap the striking consistency in size. Left to right, 100 nanoliters, 200 nanoliters, and 300 nanoliters. This last repetitive touch-off demonstration gives an excellent model for you to better appreciate the generous, stable excursion distance inherent in the DRD differential mechanism. Observe the distance that the pistons move together now. To dispense 0.1 microliters, 100 nanoliters, 24 thousandths of an inch. For 200 nanoliters, 48 thousandths of an inch. For 300 nanoliters, 62 thousandths of an inch. Very generous distances. Again, 100 nanoliters, observe the visible, ample 24 thousandths of an inch. 200 nanoliters, 48 thousandths of an inch. 300 nanoliters, 62 thousandths of an inch. Same distances that a 10 microliter syringe would move to meter those volumes, except unlike a 10 microliter syringe, which would be hopelessly impractical because of bubble hang-up and sealing problems and leaking, this unique patented differential mechanism of the DRD Lil Squirt uses these husky pistons with robust compression seals and can meter these tiny, tiny volumes as finely as if you were moving a pin or a needle through that liquid.